We are going to continue our discussion about the decision trees, and we are going to finish the decision tree today. In the last lecture, we talked about one of the problems with the decision tree. That is, the tree building algorithm itself is a greedy algorithm. So, if we are aiming for a optimal decision tree, and the short answer is we ain't gonna have that, and that is just only one problem, and that problem can be fixed with random forest. Okay, so today we are gonna move on and talk about another problem, that is, the overgrowing of a decision tree. So what does that mean? Let me bring you back to the lecture 8. So on lecture 8, we visualized a decision tree, and that was on the very small kyphosis data, right? So from this decision tree, and then we just have 60-ish nodes, and then we split, and we only have roughly 4 or 5 features, so really small data set. And then if you visualize the tree, and you may find that the tree is actually very large. So why? Because we split and split, and eventually we got a bunch of pure nodes. Well, you see, this the Gini values, and they're all zeros. Like for this one, the Gini is 0, and then only one sample, and then it is 0, 1. So only one sample, it is on class 1, for example. And for if we want to just let the tree grow and grow, and eventually, it's very likely that we are going to end up with a very tall tree or a very deep tree, and on the leaves we have 100% pure leaves, but the leaf sizes, they tend to be very small. So let me give you an example here. So if we want to just stop the growing of the tree here, and what do we get? We got a node of 6 nodes in total, right? And then we split and split, and eventually we got pure nodes, and this might be a overgrown tree in this case, because we got too deep, and then using the training data set, we got perfect trees. Because if we use this tree for and then run the training set again on this decision tree, and then we are going to have a perfect model. However, if we send a testing data set, a test set that we haven't used to build the tree, and we may have a bad result. What is that? That is overfitting, right? So if we just allow the tree to grow to 100% pure leaves, and we end up with a overgrown tree, and then that is a overfitting. We don't want to have that. So how do we avoid that? And in this case, if we want to regularize the growth of the tree, and we call that regularization. Okay, and then in the decision tree, there are a lot of the parameters we can control. So for example, a mean sample split, so that is the minimum of the number of the samples a node must have before it can be split. So let me come back to this again. So if we specify this hyperparameter to be 8, for example, and then this means, we have to have at least 8 samples in a node before it can be further split. So in this case, we have a total of 6 samples in this node. So this node is already too small to split again. So in this case, we are gonna keep this node as is. So this is just one of the way that we can enforce the regularization, and then stop the tree from overgrowing. So what is the problem of the overgrowing? So we are going to use a random generated dataset, and as you can see, that we have a yellow class, which is a moon shape, and then we have a blue class, which is another moon shape. Okay, so if we don't have any restriction, and then we decide we just let the decision tree to grow, and eventually if we plot the decision boundary, it will be like this. So this is the one on the left side. So like for this one, there is a blue sample here, so this blue sample will claim just a very thin bar of the area here. And does that make sense? Probably not, right? And even worse, this one. So this is a yellow sample in the blue sample area. However, using this one and then the yellow class actually claimed a corner of the possible space of the feature, and this is bad. Well, even though if you use this as the uh, if we evaluate this decision tree with a training set again, it might be a perfect model. However, this is a overfitting. So if we want to specify the mean sample leaf to be a 4, so what does the mean samples leaf mean? So let me find it here. So this one, mean sample leaf, that is the minimum number of the samples of a leaf node must have. Okay, so for this case, well, if we have a leaf and then a leaf has, say, 4 samples and 3 from one class and 1 from another class. So 3 from one class and 1 from another one. So in this case, we are going to keep this leaf as is. So even if we send the training set into the tree model again, well, it won't be 100% correct. Well, that is okay, because that is the cost we pay to prevent the tree from the overgrowing. So you may assume that in this case, when we draw the decision boundaries, and then we won't have a perfect model. So for example, like this sample, it will be classified as into the yellow class for sure. Well, this is the price we pay, no problem. However, for this model, this model is looks more to be a reasonable model to me, because at least we don't have it overfitted in this case. So this is just the part we want to pay attention to. And when we create a decision tree model, we don't want to have this decision tree to just grow freely, and then even though it is a perfect model for the training set, it might be a terrible model for the testing side. So what do we do? So there are a bunch of the hyperparameters, and this philosophy should be you either increasing the minimum of something hyperparameter or reducing the maximum of something hyperparameters. So this is how you can possibly regularize the growth of the decision tree model. And then there are a bunch of the hyperparameters, like the mean sample split and the mean sample leaf, and then the max leaf nodes. So those are the hyperparameters you can control to enforce some regularization of the decision tree. So this is one approach. So if you want to stop a decision tree from overgrowing, and then you can try to enforce some regularization. And there's also another way, which is we just let the tree to grow, and after this tree is fully grown, and then we do some cut. We cut some of the branches, and then we call that pruning. So regularization or pruning, both of them are the approaches to regularize a tree. And then for the regularization, it is used more often. So one sentence sum up: decision tree may overgrow if we don't put any hyperparameters. So to make a better decision tree, please go ahead and then try to enforce some of the regularization. Okay, so I will see you in the next video.